Are we ready to get started? Okay, this is you. You're a manager. You got these employees. You're brand new. And you're told, hey, here you go. Work out next week's schedule. Here's everybody's names. Here's the hours that are available. Everybody works an 8-hour shift. You have to decide what time you're going to have each employee start. All right? They can either start at 8 a.m., noon, 4, 8, midnight, or 4. 1, 2, 3, 4, 5. There's 6 different start times. And you have to assign everybody. And they're there for 8 hours, whatever time you schedule them for. So if you schedule them for 8 a.m., they're there all the way till 4 p.m., 8 hours. But here's what you were told about every 4 hours. Well, let me repeat this. If an employee starts at 8, they're there all the way till 4. If an employee starts at noon, they're there till 8. But here, every 4 hours, the goal is whatever amount of employees you're scheduling for each time, there's got to be 5 of them there, here at our business for these 4 hours. There's got to be 6, 10, 7, 4 for those 4 hours, and 6 for those 4 hours. So think about this. Less than equal, greater than equal, or equal. There has to be at least 5, at least 6, at least 10 during those 4 hours. Less than equal, greater than equal, or equal. Tell me now. Greater than equal, because it has to be at least that many. So I can see 6 constraints here, greater than equal, greater than equal, greater, greater, greater. Now just to review for chapter 3, if you were told to find the slack or surplus, whatever amount you calculated for each of these would have ended up being slack or surplus. Surplus because? Who said? Surplus because what? Greater than equal. That's all you need to know, whether it's slack or surplus, whether it's greater than or less than equal. Greater than equal is surplus, less than equal is slack. That's such an easy point. Right? I keep emphasizing because I don't want you guys to lose the easy ones. You got enough chances to lose it on the hard ones. So you have to work out a schedule, taking into consideration that every employee, no matter what time they start, stays for 8 hours. What I'm trying to point out, they're there for 2 of these, not just 1. Right? And you don't want to spend all day trying to figure out how many should I schedule at this time, how many at this time, does it fulfill this? You want to put it in a linear programming problem so you can do it fast. Companies do this to schedule employees all the time. This is very common. So, you already told me the constraints are greater than, there's the 6 constraints. Let's identify one variable. Or tell me how many variables, how many decisions that need to be made as you as a manager for this problem. How many decisions you got to make? 6. What are they, Matt? No. That's the constraints. Those are the 6 constraints. What is it?
The start times.
Start times. How many should I schedule to start at 8? How many should I schedule to start at noon? And da-da-da, and da-da-da, and da-da-da. There's 6 start times. That's what you're trying to do as a manager, is how many should I schedule at each start time to cover each of these 4-hour intervals. So I'm just going to go x1 equals number of employees starting at 9 a.m. or not 8. Is it 8 a.m. or 9? 8. Yeah, my head's in the X2 all the way down is going to be number of employees starting at, and this is going to be what's the next start time? Noon?
Yep.
Noon. And then the next start time is 4. And the next start time is 8, right? And so on and so on. So you have 6 variables with 6 start times. How many? And here's how many you're going to have there. Now here's the trick. The company says, we want to keep the labor cost as low as possible. I'm going to add something that's not the story. Every person makes the exact same wage, exact same hourly wage, salary, or whatever. We want to keep costs as low as possible. So, this is obviously what kind of an objective function, max or min? Minimize. But, what is it we're trying to minimize, do you think? To keep costs as low, we are not even given costs. The number of employees working is what you want to minimize, because they're all making the same amount. So the least amount you have to schedule is the lowest you can get the cost then. So I'm going to go min, and I'm not putting any numbers with the variables, because it doesn't say here's how much X1 you'd have to pay per hour, or here's how much, then you would put the numbers. But in this case, since they're all getting paid the same, as long as we minimize however many employees we're scheduling all together, we will keep the cost, labor cost, as low as possible. There's what we're minimizing. Now, here's where everybody kind of can't see the big picture is when you're writing these left-hand side, these constraints. These constraints are all greater than equal to, and then what's the first number? Is that 5? Yeah. I'm just going to do the first two real quick. There it is. This 5 represents the time interval from 8 a.m. to noon. So do you understand? What do you think the left-hand side should be there? Do you see what's going on here? Jack, you look like you're ready. Huh? No, okay. Go ahead.
Would be x1 plus x2?
He's saying x1, the number that started at 9 a.m., or started at 8 a.m., excuse me, they're for sure there, and x2, the ones that start at noon, but they'll be just coming to work when this shift ends. But I like the thinking. What?
4 a.m.
4 a.m., that's right, which was represented by what variable?
X6.
So those who are on the second half of their shift started at 4 a.m., they're still there at 8 a.m. for the second half of their shift, and they're going to overlap with those you assigned to start at 9 a.m. because they're at the first half of their shift. Here's the overlapping. They're at the last half of their shift, they're at the first half of their shift, they're both there from 8 to noon, and when we add these up, it's got to be 5 or more. And then you just use that logic all the way down. Those from at 8 a.m. are there for the second half of their shift, plus those that start at noon are at the first half of their shift, and this goes these 4 hours from noon to 4 p.m. Here's our overlapping, second half of the shift, first half of the shift, greater than or equal to 6. There's the logic behind it. And you just keep going like that, two more on the left-hand side for each one. And that's the whole problem, right there. Now, you're now entering into Excel. You're now entering it into Excel. Do I have the right problem? Mm-hmm. Look at this. X1 plus X6 greater than or equal to 5. X1 plus X2 greater than or equal to 6. X2 plus X3, X3 plus X4, X4 plus X5, X5 plus X6. Wherever the overlapping is taking place, because the employees are there for 8 hours, and since the intervals are only 4 hours, some employees are at the last half of their shift, some employees are at the first half of their shift, and that's the ones you got to line up. Now, our objective function, it just says x1 plus x2 plus x3 plus x4 plus x5 plus x6. 1, 1, 1, 1, 1, 1. Just 1. Even though I didn't put any 1s next to here, to have that there means 1, 1, 1, 1. You ready? Here's where the optimal values. This will tell you exactly how many to schedule for each one of these variables. How many should start at 8 a.m. How many should start at noon. Here we're minimizing however many should start at 8 a.m. times 1x1 is going to be there, plus however many times 1, plus however many times 1, plus, plus, plus. It's just adding this. This is what we're telling Solver to make as low, least amount of employees that we have to schedule overall as possible. So that's why you have F16 and F12. Before I go here, I know it, all of these are using the 16, row 16. What is the 16 row being multiplied by for this constraint? What row number? For this constraint. Hit me. What row number? 6. What row number here? What row number? Row. 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 All times 16. Every one of these will have 16 times row 6, row 7, row 8, row 9, row 10, row 11 times 16. Go ahead, Al.
I'm confused. Why is the objective function 1 all the way across?
Because it's just x1 plus x2 plus x3 plus x4 plus x5 plus 6. There's no numbers in front of them. You have to assume they're all 1s. So it's there's 1 times x1, 1 times x2, 1 times x3. All right, I'm going to solve it. You ready? Before I open up Solver, because I know the answer is going to be, if I could get some? No. Oh, okay. Before I open up Solver, If I said to you right now, you have this picture, you have solver in the picture, and I said, I'm trying to think of the name at the very top. What would you enter for, I think it says set objective is the first words, I can't remember if anybody's got it open. What would you enter for set objective, I think it says. What would you enter on solver? I don't want to open it up because I already have the answer there. What cell location would you enter, or cell locations?
E18.
E18, right there. It's the objective function, wherever that's being calculated is what you would enter. The next one says, changing variables something. And then you would have to tell it what. What would you put in solver for the second one? Oh, first you tell it it's a min, I forgot. Then it's saying, changing variables something. By changing what? It wants to know the cell locations of whatever's going to be changed. What would you enter? No. No, this would be when we get to the constraint part, but we're just at that part above the constraint.
E16 through J16?
That's right. It's asking where do you want the optimal solution to be placed and changed to figure out what to do here. And you're going to say E16 colon J16, meaning that whole row between those two is what you're going to enter. Now let's do a constraint. Is that you? Somebody said you have to do a constraint. Matt, you ready? We're going to do a constraint now. We're in the constraint section. The pop-up window just opened up. It's asking you for the left side. It just says left side. What are you entering? You're doing a constraint. Let's say you're doing constraint 1. What do you enter on solver for the left side? Say it.
E22.
Exactly. E22. Then it has a little window in the middle that pops open, and it gives you all these options. What are you going to click on for the options? I don't even want to tell you. What do you click on? Greater than. Very good. Then it get to the right side. What are you entering for the right side for this first constraint? What is it? Not 5. No way.
L22.
Is that what you said? L22. And then you go to saying you're going now. I'm doing the second constraint. E23 pop up greater than equal. These are all greater than equal. And then L23. You do that for each one, and it looks like this. Data solver. No. That's never happened. So I must have. I don't know what I did. Switch this to minimum. You told me set objective is going to be this cell right here. Then you told me by changing variable cells, you said right here, 16 all the way to 16. Going constraints, I'm going fast. This is all review. I thought this was done. Left side, are they all greater than equal? I'm going to take the shortcut, and they're all the same sign. I'm doing the shortcut. Jump in.
We did not check the box for.
Not yet. We will, though. That's coming up. He's saying for non-negative, is that what you're saying? Non-negative, linear, whatever. Yeah, you got to check that box. Left side, I'm doing all of these at one time because they're all greater than equal. So I'm putting them together at the same time. Switching this to greater than equal. The right side would be all of these to do them all at one time because they're all greater than equal. So I have 6 and 6. 22 through 27. 22 through 27, hit OK. 22 through 27 on the left-hand side, greater than equal to. 22 through 27 in column I for the right-hand side. Now I'm checking the box, make them all there. What about this? What should this be on over here?
Simplex.
Simplex method. That's all we're using in this class. And then solve. You ready? What reports do I want to make sure to click on if this were being handed in as homework or something? Answers and sensitivity, just to practice, we'll put them on there. Boom. All right, my question for you is, how many employees are you scheduling to show up at noon for the beginning of their shift? How many employees starting at noon? 3. That's right. Everybody see it? Noon was represented by X2. The optimal value for X2 is 3. 3 employees scheduled to start at 9. 3 employees scheduled at noon. 7 employees to start at 4 p.m. None start at 8 at night. Was that midnight? Is that midnight? Yeah. Midnight 4, and then 4 in the morning. You got 2 coming on there. Now, I want to give you a heads up. There's a lot of these kind of employee type questions. There is an optimal solution that's different than this. Meaning, an alternative optimal solution. There is a combination of scheduling the employees that will get the same thing. The least amount of employees we have to schedule are 19 to cover all those amount of employees for each one of those intervals. Even if you go after an alternative solution, you will never get better than 19. 19 is the best you can get. So if this looks okay, you just run with it. You don't sit there and go, okay, wait, there could be something better. I want somebody to start at this time or something like that. But you'll never get it better than 19, even if you do find an alternate. So as long as this is okay, you just go with it. You don't spend the time looking for an alternative. That's the best it can get, 19. This process finds the best answer, and it may, as fast as it can, and that's the first right answer. But some of them do have alternative optimal solutions, but it will never get you better than that. There'll also be 19 if there is an alternative. Everybody see this one? Everybody knows now how to schedule people, right? If you have to have exactly these kind of shifts and stuff. Just kind of a basic so you understand. Let's now go to the second of the 3 different ones we're going to study today. And then don't forget we have an in-class. We need at least 15 minutes for this in-class. Market research. Chapter 4 is all about whatever scenario. I guarantee you're going to have a problem on your quiz where it's a story problem like this, and at the end it's going to say, create or make a linear programming model. And then, just in case, I'm always worried that somebody doesn't remember what make a linear programming model means, so I'll put in parentheses, define your variables, write your objective function, write your constraints, do not solve. So you'll see that on the quiz, but a problem with a story like this. It's just, all this is about is you being able to figure out what decisions need to be made, and then turning them into variables, then writing the objective function and your constraints. This is what this is all about. You ready? Market survey, it specializes in evaluating consumer reactions. They have new products, services, advertising campaigns. A client firm requested your company, you, to assist in ascertaining a consumer reaction to a recently marketed household product. During the meetings, this is your information gathering meeting, that you're getting ready to put this together. This will be, you're working for this advertising firm. This advertising firm happens to do market research as part of the thing. So you're information gathering with the clients right now. And they're saying, hey, during this meeting, you agreed to conduct the door-to-door personal interviews to obtain the information they want. You have agreed to make sure that you're going door-to-door and asking households with children and asking households that don't have children. And you're also going to do some of them during the day and some of them at night. Let me repeat this. I want you to see how many possibilities there are. There's doing interviews during the day with households with no children and households with children. There's doing interviews at night with households with no children and households with children. You see what I'm getting at? So there's 4 possibilities. Does that sound right? 4 possibilities. Here's some additional information you gathered in the information gathering meeting. The client said, we want 1,000 interviews. All right? So greater than or less than, or equal? They didn't tell me we want at least 1,000. They didn't say we want no more than 1,000. They said we want 1,000 interviews. We want 1,000 of them exactly. This is one of those rare equals. I don't know, maybe I'm misreading. The client said, and we want at least 400 of these thousands to be from households with children. At least 400 with households with children. Greater than or less than or equal 400? Greater than equal 400. We want at least 400. They also said that we want interviews of at least 400 households without children. Greater than equal, less than equal, or equal? Greater than equal, 400. Now, we're getting to the hard one. No, not yet. Coming up. The total number of households interviewed during the evening, think about this, total number of households during the evening must be at least as great as the number of households interviewed during the day. We'll get to that one in a minute because we haven't defined our variables yet. This isn't about a number, this is about the variable. 4 says at least 40% of the interviews for households with children must be conducted during the evening. We'll get to that in a minute once we define our variables. And the last one says at least 60% of the interviews conducted for the households must be households without children conducted during the evening. Now, how many decisions are there? You're the ones putting this together. What is the decision you've got to come up with why you're going to do this linear programming model? Why? What decisions? You have to decide. You're about to hire the people going out to do the questions. Go ahead, hit me. Anybody?
Children during the day, without children
So,
during the day.
wait, it's not just children, date,
Interviewing.
interview. How many different interviews are there? 4. The client wants you to come back and say, what are you doing with these 1,000 interviews to meet all of our needs? Those are the 4 variables. You're coming back to tell them, we're going to do this many interviews during the day with households with children. We're going to do this many interviews during the day with households with no children. Then we're doing this many interviews in the evening, households without children. This many interviews in the evening, households with. Those are the 4 variables right here. And we have calculated, because we got to pay a premium for the people who have to go out there in the nighttime, we've calculated this would be the cost per interview during the day or night. There's also a little more cost if they have children, because there's additional questions that will take a little longer. So the least expensive is if they have no children, daytime. No children daytime, a little more expensive during the day because our employees have to be there a little longer. That's why it costs a little more with children. Evening, we got to pay a premium. Nobody wants to work at night. But if there's no children, they can do it quicker than if it does have children. It takes a little longer, so you got a little bit there. Here's our cost. Let's turn these into variables. I'm just going to use X1, X2. I don't remember what it says on the next page, but I'm going to use X1 as, I'm at the top there. What's that? Day children? Daytime, number of interviews. I need lots of words on your definitions. Number of interviews, day, what is that? With children. Number of interviews, daytime, children. X2, number of interviews, daytime, without children. X3, number of interviews, that's on each of these, okay? Number of interviews. Evening with children. This would be X4, would be evening, number of interviews, evening without children. Those are the 4 decisions that have to be made. X1, X2, X3, X4 for this case. Now we're going back to our notes from the information gathering interview with the client, and we're now going to start writing our constraints. We're going to leave the objective function off for a little bit, but, you know, what would be our objective function, by the way, as far as maximize or minimize? Min, what are we minimizing? Let me see where I can put this, right here. Min, what is it that the client wants? What is it? Someone else. Go ahead, jump in. Anyone.
Cost.
Cost of what?
Doing the interviews?
What they have to pay for the 1,000 interviews. All right. So, however many interviews we're doing during the day with children, we got to multiply by how much? $20. Is that what that one is? Yeah. $20 plus however many interviews we're doing day without children would be $18. However many interviews during the evening with children is $25, X3, plus the last one is no children during the evening, which is X4, and that's $20. There's our objective function. We took the constraints of how many, turned it into how much by multiplying it by the cost of every interview related to that one. Now this would be easy if you just said 250, 250, 250, 250, there's your 1,000 interviews. But the client said, no, we want this to be met. So now we got to take those variables and turn them into constraints based on these things that they told us. We'll start with the 1,000. They said, however many interviews you're doing with children, without children, day or night, 1,000 of them. X1 represents the number of interviews. X2 is the number of interviews. X3 is the number of interviews. And X4 is the number of interviews. However many interviews we do of each type, got to be 1,000 interviews. The next one, they said, hey, interview at least 400 households with children. Greater than or equal to 400, because it said at least, but this side's got to represent the interviews with children. Give me the variables. X1 plus X3 is both with children. However many interviews you're doing with children, has to be at least 400 of them.
Wait.
That is, what, did I do something wrong? You good? Hang on.
Isn't it x1 plus x2?
X1 is with children, X2 is
Oh,
without
with
children,
children.
X3 is with
Not
children.
with data.
So it's the ones with children, but here we go with the second one. Now you're interview at least 400 households without children. You said greater than 400, but this has to represent interviews without children. Give me the variable. X2 plus X4, the ones without children, however many interviews, got to be over 400, right? And now, you ready for this one? This is where I always say, write it like it reads. Write it like it reads, and then apply algebra. This is how I, this one, this one, this one. Write it like it reads. The word of means multiply. The word of means multiply. Almost always in these stories. So I'm going up here. The total number of households interviewed during the evening, it's got right there. The total number of households interviewed during the evening. Give me the variables that represent household interviews in the evening. X4. However many interviews are during the evening, let me keep going, during the evening must be at least, there we go, must be at least as great as the number of households during that are interviewed during the day. Yeah, give me the daytime. X1 plus X2. Let me read it again. It says the total number of households that are interviewed during the evening must be greater than, or it must be at least, must be at least as great as the number of households during the day. Use algebra. This is not a complete constraint. You cannot have variables on the right-hand side, only numbers on the right-hand side. We got to get the variables to the left. Minus x1 on both sides, minus x2 on both sides. This now becomes x3 plus x4. You can do this in any order. Minus x1 minus x2 greater than equal to, but there's nothing left on the right. What do I do? 0. Now you have a number on the right and variables all to the left. Right, algebra. Okay, now we have 2 more. At least 40% of the interviews for households with children, at least 40% of the households with children must be conducted during the evening. Okay, first of all, I'm going to start at the end of that. Must be conducted in the evening. At least 40% of the interviews with children must be during the evening. What variable represents interviews in the evening with children? X3. Now I'm reading it again. X3, which is the interviews in the evening with children, must be at least, give me at least, greater than equal, at least 40%. So I'm doing 40.40 of times of at least 40% of interviews for households with children. What represents interviews with households with children? X1 and X3 are with children, right? X1 plus X3. I heard something in here. No. Abigail? Okay. Now, you wrote it just like it reads. All I did was take that last little part and move it to the front. I'm going to say it again. Interviews conducted in the evening with households with children must be at least, X3 with children, evening, must be at least, greater than equal to, 40% of, 40% times, interviews households with children. X1, X3. Apply algebra. You ready? I'm taking 40% times each one of the variables first. I'm trying to figure out where I can put this. It's going to be off camera here, so I'm going to say everything I'm doing. I'm doing X3 greater than equal to, I'm multiplying 40% times both of those, 0.4 X1 plus 0.4 X3. Now I'm using algebra to bring everything from the right to the left. So I'm subtracting 0.4 X1, and then I'm also going to subtract 0.4 X3. But look at, I have X3 on the right, or on the left already. So I'm going to have a negative 0.4 X1 plus X3 minus 0.4 X3. What do I have left for X3s? A positive 1 minus 0.4, 0.6 X3. Greater than equal to. I took 1 X3, subtracted 0.4 X3 to both sides. I get a positive 0.6 X3s left. Minus 0.4x1 plus 0.6x3 greater than or equal to, what's left on the right? Zero. Now that constraint's ready to enter into the software or Excel, because all the variables are on the left side. And when I enter this one, I got to put negative 0.4, positive 0.6 underneath x1 and x3 here.
Why can't we have variables on the right side?
You can't enter them into the software. The software only takes numbers on the right side, and variables are all to the left. You have to move them. Same with Excel. You got to move them all to the left side. Only numbers can be on the right. Last one. At least 60% of the interviews for households without children must be conducted during the evening. Evening without children is what variable? Evening without children. X4, is that what it is? X4 must be, does it say at least?
Yeah.
At least 60% times of the interview of households without children. What variables represent households without children? X2 plus X4. All the households we interview without children, the ones at evening have to be greater than or equal to 60% of all those. Again, I'll put 0.6x2 plus 0.6x4. I'm subtracting 0.6x2 on both sides. I'm subtracting 0.6x4 on both sides. Subtract, subtract. That's gone. Over here, I got, ready? Hang on. I've got negative 0.6x2, because I'm moving it from the right to the left. Then I have a positive x4, and I got to subtract a 0.6x4. What would be left? Positive 0.4. 1 minus 0.6. A positive 0.4x4 greater than or equal to, on the right, nothing's left, 0. And now I can enter the software. Underneath x2, I'm putting a negative 0.6. Underneath x4, I'm putting a 0.4. And it looks like this. There's my negative 0.4. There's my positive 0.6. Here's my negative 0.6. Here's my positive 0.4 for the other one. Here's my negative 1, positive 1, negative 1, positive 1, which was right here. Negative 1, negative 1, positive, positive, right? Just like this. What happened here? We have the variables in different orders. Same thing though. Here's my cost for this type of interview. 2025. Ours happens to be 2018. We did in different orders all. Here's the 2025. Then 18 and 20. There's the 18. There's the 20. I'm going to solve it just like any other problem. Here's all our left-hand sides. This is an equal sign. That's greater than equal. I can group these greater than equals together, but the equal sign has to be its own constraint on solving. You get data. How many interviews? Look at this, another blank one. Help me out. All right. Is this a min or a max? Min. Click on min. Set objective. What cell location? Anyone? E17. E17, I heard. Is that right? Then it says, by changing variable cells, what cells need to be changed? Very good. E15 through H15. E15 colon H15. At this point, if you don't have dollar signs, I'm not marking you off. We're heading to where you need to make sure to put dollar signs. Now we're going to do the constraint. The first constraint's an equal sign, so I got to do it by myself. Left side is right there. We got to change this to equals, and the right side is right there. I'm going to, instead of saying OK and going back to C, I'm going to just click add. I'm going to go straight to the second one. Now these are all greater than equal, so I'm just putting them all together. There it is. I've got the cell 20 through 24. These are greater than equal, all of them, so I'm going to highlight greater than equal. I'm on the right side. I got to do cell 20 through 24. There it is. Now I hit OK. Here's the first one. E19 equals J19, is that what it says? E20 through E24 on the left-hand sides. J20 through J24 on the right-hand sides here. Check the box right here. Make sure we're on the simplex method, and we are. You ready? Is it going to be 250, 250, 250? 250? Does anybody have a guess what would be the most interviews you have to do to fulfill all these limitations the client gave you? Would it be the daytime children, evening children, daytime no children, evening no children? Which is going to be the biggest? Somebody's looking for power. I'm gonna do my reports, blah, blah, blah. What's this? No, I did, but every time I do have another one, it jumps to the other spreadsheet. Why does it do that? I don't know. Here it is. We're gonna do 240. It's evening, no children. Okay, evening, no children is the biggest one, 360. 240, daytime with children. Evening with children is the least amount, 160. Daytime, no children, 240. Evening, no children, 360. Meets all the client's requirements. Exactly what they wanted on the amount of daytime with children, without children. There's 1,000 of them there. And the least amount of money it's going to cost to get all 1,000 of these done is how much? There it is, yeah. The objective function was minimizing that cost. And look for the objective function value. $20,320 is the cost for gathering the data you want. Now, a marketing company, when they do these kind of research projects, in my experience, they add a 10%. That's their thing too. But if they're selling a commercial, they don't add a fee to the client. You know why? In the old days, I don't know if anything's changed, the TV stations, the radio stations, and the newspaper, if an advertising firm brings them business and says, I have a client, we're going to schedule this many TV ads, this many radio, the TV stations pass on a commission to the advertising firm. So you don't have to market. So if the client went directly to the TV station, they're paying the same price. If they went through you, an advertising company that you work for or started on your own, they're paying the same price, then no markup. Instead of the TV station paying one of their salespeople the commission, they're paying the advertising company the commission, which would be like 10%. So that's how it used to always work in advertising back in my day. Now, I don't know if it's still that way, but I would imagine it probably is. But with this kind of thing, there's nobody to pay anything, so you have to put a markup in it. But you're transparent. You don't say, oh, our fees built into those costs. You give exactly what you have to spend to do this for them, and then you say, and then our fee is 10%. This whole thing's going to come to like, you got to analyze all this and put it all together for them and give them results. So you're maybe at 25,000, 30,000. You're getting paid for that stuff plus the 10% of gathering, so you got another 2,000 coming to this part of it. You'll put 10% of gathering the data, 2,000 to us, the research company. That's how it's usually works. One more.
Why is our constraint 5 and 6 is 0?
We had to make it 0 because when we got everything to one side here.
I mean on both sides there's 0.
Oh, what is 5 and 6? What is it? Yeah, the 40 and 60%. Yeah, we got it to exactly where it should be. We are meeting exactly the 40 and 60%. We're not going over or under. These end up being binding constraints, actually. We're exactly at the 40 and 60% that was required for each of these situations. I think one was with children, one's without, or evening, or something like that. And really, we're at the point of where I should be asking you questions when you look at this, that turning it into words, like Peter's did. Like, not just how many evening no children interviews need to be done, and you look on here and you recognize, oh, evening no children 360, but it would be something like, what was the 400? This was, oh, how are you doing more than 400 interviews with children, households with children? Are you doing the over 400? You go straight to this constraint, and you say, yeah, we're doing exactly 400. What about the other one? It was 400, what is this? Without children. Are you doing exactly the 400 without children that we asked for? Yeah, we're doing 600. We're doing at least the 400 you wanted, plus an extra 200, because of this other constraint that you wanted that inflated that a little. And that's how the 1,000 are being spread out. All right, one more for my finance majors. Blah, 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 blah. This is all we talked about, blah, blah, blah. There it is. Here's how many. Here's our cost, total 1,000 interviews, 360 with no children evening, same results. And here's our finance majors. I just want to see that you're here. So finance majors here. Okay. This is common as far as putting a tailored portfolio together for a client. I want to tell you the number one thing that financial advisors or financial companies are doing out there is all about risk tolerance now. Things have all changed. I have a bunch of people who kind of rely on my advice for their financial investments, and some sometimes they'll take me to their meetings that they go to where they're trying to make a decision, usually it's $500,000. Do we have this in the right place? What should we do with it? I want you to hear what my financial advisor is saying, because it's the exact opposite of what you're saying. And they'll take me there. Financial advisors are all about how much risk tolerance will the client have. The higher the risk tolerance, the more risky they're going to make the investments for you to try to make the most money possible. The more conservative risk tolerance you have, they're going to be recommending that the investments are more conservative, not necessarily going after that big return, but instead protecting the money and still getting as high a return as possible. That's what risk tolerance is. And what a lot of people don't realize is you should always lower your risk tolerance the older you get. When you get into 50 years old and above, your whole financial mindset needs to shift from making as much as possible from investments to protecting as much as possible with your investments. That's the mind shift. Because after 50, if we have another crash, you don't have enough time to get it all back. That's the philosophy. So you turn to more conservative, where if a crash takes place, you still have your nest egg to retire that you worked so hard to get to. That's what's going to happen. That's what this degree is doing for you. You get the piece of paper to sit across from somebody to then finally get the job that you could have done before you got the piece of paper, but nobody would hear you say you could do it until you got the piece of paper, because they wouldn't even interview you. Now you're doing the job. Your goal should be stay under what you're making with your expenditures and save. Save, 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 save. That's the key. That's what it's all about. And the stress goes away the more you save. The stress goes away, the stress goes away. And you're ready for retirement stress-free. All right. And it just reminded me of a story about my dad in his wheelchair towards the end of life. He said, damn, General Motors got the best of me. You know, he's dwelling on things. He's almost done with life. I said, Dad, you retired at 55 from General Motors after 30 years. They paid you, you know, I know exactly how much General Motors was paying and stuff. I said, they're paying you this much per month. You've been 55, you're 82. Let's multiply that many months times what they paid you. It came out to over $1 million. He went, well, I got the best of them. He goes, yeah, they paid you over $1 million after you left the company. I don't think they got the best of you. You know, right? I mean, you just gotta, that's what it's about. You get out. And you cannot live off just that pension. You gotta have the Social Security with it. And you gotta have the savings that you're pulling out towards the end of life with it too. To keep your lifestyle the way you want it, to be comfortable and to not have stress. Here's my finance major's problem right here. The client comes in, these are possible blah blah blah. This is it. Portfolio selection, the objective function usually is to maximize the expected return, or older clients, the objective may be to minimize risk, you know, still beat inflation, is kind of the policy. Here we go. Portfolio selection problems involved, this is still more, objective functions involved, blah, blah, blah. Let's get to this, here we go. The client walked in. You're working on a mutual fund company. You're located in New York. You just obtained $100,000 from a client who wants investment opportunities that you need to recommend. They're asking you, what would you do with this $100,000? They gave you some limitations or some things that you want. Based on we just found out at our company, based on our current investments, from our top financial analysts, we're recommending these new investments to be made in the oil industry, the steel industry, and government bonds. This is all we're working with the clients for this next 30 days or something. All right? Client walks in, $100,000. These are the choices, the only choices that you have to put together a portfolio for them, how to invest $100,000 in these choices. And it says, specifically, the analysts identify these 5 opportunities with their expected annual rates of return. Historically, 7.3%, 10.3, 6.4, 7.5, 4.5. Now, the client says, I don't want neither industry, oil or steel, should receive more than $50,000. Because the client's saying that's too much risk. So however much you're going to put in oil and steel, don't go over $50,000 of the $100,000. Let me start right here. Usual situation. 50,000, no more than 50,000 in either category. Is that a less than equal, greater than equal, or equal to 50,000?
Wait, so is this for like, so it's like 50,000 each, or is it like 50,000
Each,
total?
each, total for one industry, but there's two industries, so each
Okay.
of the two industries.
Okay.
So I've got less than equal 50,000, okay?
Shouldn't we have a less than equal 100,000?
Not yet, almost. And I just want to mention, this says two industries. So we're going to have two less than equal 50,000. When we finally figure out what the decisions are, what the variables are, this left-hand side is going to represent whatever's being invested in oil. This is going to represent whatever's being invested in steel. All right. Now it says government bonds should be at least 25% of the steel industry investment. Whatever government bond should be at least 0.25 of times, and then in the parentheses is going to represent steel industry. Now before I go on, how many decisions do you think there are that you're trying to figure out for the client? I see 5. Anybody agree? I see another 5. I see another 5. Yeah, this is exactly what you're trying to get. You're trying to decide how much should be invested in each one of these 5 investments. Go right down here. I don't want to write it down. X1 is Atlantic Oil. X2 is Pacific Oil. Midwest Steel is X3, X4, X5. I'll keep coming back here because I'm going to forget what I just said. But now, let's look at this. It said, don't put any more than 50,000 in the oil industry. This left-hand side is going to represent oil, the amount we're going to invest in oil. Let's define one variable. X1 equals the amount invested in, what's the first one called? Atlantic Oil. Atlantic Oil. X2, it will say the amount to invest or invested in Pacific Oil. X3, the amount. The point I'm trying to make is, when you define your variables, you need some words. You can't say X1, Atlantic Oil. X2, Pacific Steel, oil. I need to hear amount to invest, number of shares, something that gives more meaning than it's just Atlantic Oil. Okay, so you need more words. I'm trying to give you points on this. This is a big deal, very common error. Someone in a hurry will just put X1 equals X2, X3, X4, X5. And that's semi-defining your variables. I'll accept that because you're in a hurry, but you should be adding the words amount to invest in, amount to invest in. In this case, that's what we're deciding. How much should be invested? All right, let's keep going. Now this one said 50,000, no more than 50,000 in the oil industry. So give me the variables that represent the oil industry. That's right, X1, however much in Atlantic Oil, plus however much in the other oil companies, Pacific Oil, can't be more than 50,000. Then it says no more than 50,000 in the steel industry. Hey, why don't you guys tell me? We got to do the in class.